Alright, let's get to the last problem here, number 6. Um, they're giving you the graph and they tell you that this is the graph of f, and they have a semicircle here and looks like a semi-ellipse here, which they won't ask you to find the area of this for sure. Semicircle perhaps, but anyway, um, they tell you that the function g in terms of f of x is set up by this integral. And then they have this little piece of information here that's a little extra, and it's a little bit puzzling. I think it's just there to try to confuse you. Notice how this -2 and this -2 match up. If you were to find g at -2, you would replace this with -2 right here with this x. So you have the integral from -2 to -2, so that's always equal to 0. And so I don't think that this is really going to be important in this problem, so I'm going to just erase that. It's kind of a distractor, I think. But anyway, let me just remind you of this fact here, that if you take the derivative of the left side, you're taking the derivative of the right side. So g prime is the derivative of this. And when you take the derivative of the integral and you have it in terms of x, and it's just a 1x, right? You don't have to use the chain rule. You just simply replace it, right? So anyway, what I like to do is just so I remind myself that this is the derivative of g. So they're asking us to find on part A talks about concavity, and they want to know when is it concaved downward. So concave down occurs when the second derivative is negative or less than 0. So I'm just going to draw tangent lines here. The derivative here will be positive. Derivative here is 0. Derivative here is negative. Remains negative all the way down here. It's getting less negative, and then it hits 0 at, I guess we have to assume that that's a 1.5, and it looks like it starts turning. So we have positives over here, we have 0 here, we have negatives all the way along here. It's 0 here, and then it turns positive again. So justifying your answer there, you have to mention that you could say since f of x is equal to g prime of x, you could say that the second derivative is negative on the interval from what? -1 to 1.5. And then of course you have your inflection points here. So this would probably be good justification. Alright, so part B, they're telling us that the equation of the line tangent to the graph at the point where x equals 0, so where x equals 0, is equal to y equals mx plus 7. They want you to know, they want to ask what is the value for m. And since they're asking us about g, how do you find a tangent line to g? You look at its derivative. And since we know this fact right here, that this graph f of x equals g prime, so what would g prime at 0 equal to? You just go and find out what the y value is for the function, and that's what the slope is equal to. So hopefully that helps you a little bit. And then they want to know what is the value g of 0. So that shouldn't be too hard to figure out, but you are going to have to use this equation here to help you with that. All right, part C. Part C, let me just kind of write down what part's telling you. It says the average value of f from 0 to 3 is equal to 0, right? So what does that mean mathematically? The average value would be 0 on that. That's given to you in the problem in part C. Alright. Well, one thing you could do is think about this for a second. If you multiply both sides by 3, cancels that portion out, right? So you're left with just the integral from 0 to 3 f of x dx still equal to 0, right? Okay. So how do you find g of 3? Well, you could go up here and try to calculate the area of this, which would be very difficult to do. Or you could use the fact that in part B, you found this value. You found g of 0, right? So if you found g of 0, you could set up this equation. And when you take the integral of something, what are you doing? When you're evaluating at limits, you would take the function value at 3 and subtract the antiderivative that you found at 3 and subtract it from the bottom limit of integral right here. If x equals 0, x equals 3, right? Since you already know this f of 0, you could calculate g of 3. So anyway, hopefully that'll help you a little bit. And just recall that on problems like this, if you get tricked up a little bit, you do want to at least get a few points here and there when you can. So since time is always a factor, you don't want to get hung up too long on a problem. So sometimes it's helpful to skip around on problems and then come back to them if you have time. Okay, well, I hope everyone is having success on the multiple choice part of the test, and we shall see you in class on Monday.